Thanks everyone for coming. Just move the slide along. My name is Stuart, for those that don't know me. I blog at stu.dev and I'm a Microsoft MVP. I'm a principal engineer at justeattakeaway.com. I'm a father of two, and I love all things C#, F#, and .NET. I'm also a long-time attendee of .NET Oxford, so it's a real privilege to be speaking with you today. Thank you. Just to kind of go back to the title for a second, this is a sneaky peek in terms of like C#10 isn't out yet. It's out in November. So there have been some sort of late minute minor changes along the way, and there could be any of the sort of major features I show today. There could be any reason why, there could be a sort of a show-stopping bug that means they pull it back out. So just have a bit of a caveat here is like anything I show may not make it, but hopefully we'll make it. Just a quick recap in terms of where we are at today. We are sort of somewhere here. We're currently on .NET 5 with C#9, and in November we'll get .NET 6. And the current release plan that Microsoft put out is that every single November from now on, every year, we'll get a new major version of .NET. So it's nice and simple now. We've got .NET 6, and then .NET 7, 8, 9, etc., etc. And this is also how Microsoft intend to ship C# major versions as well. So we're on C#9. But we're going to get C#10 in November. And so you can just add 4 to the .NET version for the foreseeable future, for the short-term future, to know what those pairs will be. For some of us, you can see from this diagram here, every other release will be a long-term support release. And for some of us in our working environments, we might be constrained to only being able to use long-term support releases. So for some of us, .NET 6 actually is quite exciting because it represents a major jump from .NET Core 3.1, which ships with C#8. So for some of us, we might be jumping 2 language versions when we go to C#10. And for that reason, I'm going to just call out some of the highlights from C#9, and some of these as well are kind of themes that have been extended in C#10. So just to call a few out, an important one is top-level statements. So this is the ability in your entry point of your application to, instead of having to have a class, typically a program class, and then a static void main method, you can just start writing code at the very top level within a file, and just, no indentation, just start writing code. And even if this feature doesn't really appeal to you, what's good to know is that it's really good for newcomers to language. Because they can just start writing code, and they can get familiar with C#, familiar with the tooling, and they're not bombarded with a bunch of concepts like what's a public class, what's a static void. So that's just a really a nice addition. Probably the headline feature of C#9 was records. Records are the ability to define types with a different set of defaults, where the So with a different set of defaults, where they're sort of immutable by default, and they're better suited to sort of value object semantics in domain modeling terms. And I'll be, again, touching on those later. Another great addition is pattern matching. So ever since pattern matching was introduced, it's got better and better with more patterns in each version of C#. And C#9, they added a ton of patterns, including some logical combinators. So you can start to say this pattern and that pattern, as well as saying not. So you're able to say, my favorite is, you can say my variable is not null, which is something that I've wanted to say for a long time. So it's great that you can finally say it. And then finally, source generators, which isn't strictly a language feature. It's actually more of a sort of language experience feature. It kind of sits around the language. And it's a massive addition to C#9. And we're finally in .NET 6 kind of getting some of the benefits of source generators. So Microsoft have expanded out the sort of logging APIs to use source generators and serialization libraries. But in general, if you want to play with source generators, the authoring experience has also got better. So it used to be really painful, and now it's much simpler. And they've improved the APIs there as well to make them more performant. And I'm not going to talk about source generators anymore today, but that's I have to give that a shout out because it's one of my favorite features from the C#9 timeframe. Moving on to C#10 now. If you want to code long, and I recommend you do, or if that's not convenient, you can always download this afterwards. But if you want to kind of play around with C#10, you can download the .NET 6 preview, which is currently on Preview 7. And then this is the AKA MS link you can go get it from. You can also do .NET-info, and this link will appear there. When you download that, you'll need either VS Code with the latest C# extension, or you can use Visual Studio 2022 preview. Another great option, if you don't want to sort of pollute your machine with previews, and I get it, then LinkPad is another great option. So LinkPad 6 beta, and I know Dan's a massive fan of LinkPad, and you're in good company there. You can go to preferences and enable daily Roslyn builds, and this way you're not installing anything. You're just other than LinkPad, and you're getting the daily builds as soon as features are added. And if you can't install anything at all, there's the sharplab.io, which is a really great site. I'll be showing this off later. There's a drop down at the top where you can change what branch you're using, and you can change it to the main branch. And again, as changes come in, you'll kind of be able to try them out. One caveat with that is that it doesn't ship the latest .NET 6 runtime. So whenever you're playing with new language features, sometimes you have to sort of paste in copies of the types that are needed to try it out. But definitely go off and install one of those now if you want to have a little play around. I'm going to jump into some features now. Feel free to unmute yourselves and ask questions at the end of each section if I've left something ambiguous, or if you just have any questions, I'll see if I can answer them. So this is probably one of my favorite features of C#10. So I talked briefly about C#9 with top-level statements. The thing with top-level statements is they're really nice, and they kind of get rid of a lot of boilerplate code, but they're only applicable to the entry points of your applications. And for some of us with big applications, the entry point represents a very tiny fraction of our code base. And so what's great about file scope namespaces is it's more broadly applicable. It can basically we can use it in all of our files. So here's what a very typical boring C# file might look like. You've got your namespace, you've got your class, and then within that you've got your members, and they're all indented. And if you had a method in here, the method code would also be indented again, like 3 layers in. And this is if we look over here, this sort of wasted space here is pretty criminal, right? We sort of have to pay this on every single file that we have with a namespace in. Some of us have solved this during COVID times by buying nice new widescreen monitors. I've certainly been tempted, but I haven't gone for it. But in general, for the rest of the team we work with, we try and keep our code within a certain line length. So anything that sort of wastes space like this isn't ideal. So the C# team have come up with a feature called namespace declarations. And so what you can now do is you can put a semicolon at the end of this namespace line, which turns it from a namespace block to a namespace declaration. And when you do that, you can take away the curly braces and de-indent the code. And now that namespace declaration applies for the whole file. And you can just de-indent the whole thing, which is really, really nice. What I really like about this feature is that, most language features, there's some sort of trade-off you're making. But for this, for me personally, I don't really see any trade-off. I see just like a straight win. This will be the default in the .NET 6 templates when you create new projects. But for existing projects, obviously, it'll be a big old commit if you do this, because if you do it for the whole solution, it's going to touch every file, of course. There is a Roslyn code fixer that will come up that will give you the suggestion, so you can for you. And you can see here the change is basically 3 characters per file, and then that's ignoring white space. Of course, if you include white space, it's every line in the file. So it can be quite a big commit, but I certainly I'm a big fan of this feature. So I'm going to be putting those big commits into our code bases to switch to these namespace declarations. On a similar sort of theme, we've got global usings. So if I go back to that file we just had, so this is that exact file with the namespace declaration tidied up there. But I didn't include at the top of the file the using namespaces that I'd need for this file to compile. So does anyone want to tell me, unmute themselves with a bit of audience participation, and tell me how many namespaces do we have to bring in to make this file compile. I don't know if everyone's like forced muted now. I'm going to find out.
Is it just one?
Good guess. It's a bit of a trick question, basically. It's actually 0. Because in this case, string and int are compiler keywords. They're aliases to system string and system32. Thank you. I won't press that keyboard. Yeah, I won't press that keyboard shortcut again. Right. My bad. So where was I at? Global usings. Yeah. So, right. Yeah. So there's no using statements or namespaces we need to bring in for this file. However, if we want to start bringing in other properties like a datetime property, a collection property, we bring in what I like to refer to as the usual suspects. So here I brought in a few namespaces, and one of those namespaces, excuse me, is system threading tasks, which we need for async code. But now the IDE is telling me off and saying I should get rid of that because I'm not using it. So it's telling me to get rid of it. And then I know I'm going to add it back like 10 minutes from now. So I'm just constantly having to do this bookkeeping. And so there's 3 problems here. One problem is it's a waste of space at the top of the file. 2 is that it's kind of a chore for me to keep adding these and removing these. And then finally, it's also code churn. So when I'm committing these changes in, I'm changing the top of this file constantly. And it turns out so are my teammates. We're all changing the same files. And we're all going to be clashing on the same area of the file. So it's really not ideal. And all it really represents is the sort of fragmentation of namespaces and Microsoft's sort of choices that now live with us forever. So they've introduced a new sort of a syntax we can use now where you can say global using. So at the top line here, we could say global using system. And what that would do is for the entire project, it'll bring using into each file as if we'd said using system in each file. So if we had using system in other files, we could take it out because it's implicitly available. Now, if you were to do that in this file, we can't be friends because that would be super weird, like just to randomly put a global using in an arbitrary file. So what Microsoft are recommending is that you have a dedicated file. So I suggest global usings.cs. And now we can tuck those all away in one place in your project. And now all of your files you can sort of trim down. And, you know, in this example, it's now nice and tidy. The previous namespace declarations was all about getting rid of the sort of the cruft on the left. And this is about getting rid of the cruft at the top. And so everything sort of shifts into the top left corner now. So I really like this one. There's a few more trade-offs with this one. Obviously, a bit of indirection. Something to call out in terms of the syntax here is that anything you can do in a global namespace include, for example, you might say using my alias equals something. You might use that often to disambiguate types. You can also do in a global using. Same for, in this example here, using static system console, which brings any static methods on the console class into the namespace. So you can just write line. You can also do that globally as well. One way that this is going to be leveraged with the new .NET 6 SDKs is that you can now opt into some sort of sensible defaults for this. So this is one of the things that's changing. So this changed just last week to opt in. It was originally just kind of on, but then you could opt out. So what you can now do, and this is the opt-in behavior that's in the current preview, you can add implicit usings enable into your project file, and that'll bring some defaults in, which I'll show you in a second. In fact, I'll show you now. Actually, yeah, go back for a sec. So if you're upgrading an existing project, this won't be here and won't be a problem. But when you go and create a new .NET 6 project, then this will be in here. So it's basically on for new projects, but not on unless you opt in for it in existing projects. So what this does is inside the SDK, there's actually a guard on this item group here for when you've switched it on. And when you have switched it on, it brings in these new items, which are called usings. So these are the ones you get. And what happens is when you build the code, just like with your project, your sort of project properties get turned into assembly attributes, the same happens here. This turns into auto-generated code, and it ends up in your obj folder. So you get like a global usings.g.cs file with this in. So if you're building a library or console app, the SDK will bring in these defaults. And then if you are using the worker SDK, it'll additionally bring in these Microsoft.extension namespaces, which are configuration, dependency injection, hosting, and logging. And then finally, if you're using an ASP.NET Core, web SDK, I think this is also another one they added in, this systemnet HTTP JSON. But then you also get these 4 ASP.NET Core namespaces, which are builder, hosting, HTTP, and routing. So I'm sure when you look at this, this will probably be giving you sort of flashbacks to your startup CS files. So you can imagine that when you've got this, your startup CS files can now be much, have far fewer namespaces at the top of the file. So that's kind of nice. You can also use this yourself. As I showed earlier, you can have this, global usings.cs file in your project, but you can equally put this in your own project file. And you can actually, they've made it so you can do all the things you can do in the C# syntax. So you can have an alias and you can say static true to open static. So you can do all this to the project file. You can also, like Microsoft, ship usings in NuGet packages. Now, with great power comes great responsibility. What Microsoft have found from feedback is that people don't like being just given defaults. So what they're recommending is you put this behind a guard, just as they've done. So like, let's say you're X unit and you think, here's a group of sensible sort of default namespaces I want to package up. Go ahead and do that, but put it behind an opt-in property so that people have to actually switch it on. So yeah, and on this whole feature, it's super interesting. I can imagine people have different views on this. And what goes into your global usings, I don't know, right? So if you're in sort of, if you got your own project, would you have your domain model sort of namespace brought into as a global using for your main application? That probably makes sense, right? So I don't know where we're going to land on this. This is going to be quite interesting to see how it pans out. Record structs. So as I said before, C#9 added the concept of records. So records are a way of defining a type with a different set of defaults that are better suited to value object semantics. So we get by default value equality, rather than with classes, you get reference equality by default. And that works by the compiler generating a bunch of code under the hood for us that make it do those things the way we want it to. And this is what the syntax looks like in C#9. You've got this kind of short form where you can just say record coordinates, and you kind of give it this constructor. And from the constructor, it will kind of extrapolate some properties. You also don't have to use the constructor syntax. You can kind of just define the properties yourselves. And when you do, you probably want to use the init keyword. And this is what this generated code actually generates. It generates what's called init properties. And this is a new syntax feature in C#9 as well. And what this means is, if you were to construct this using an object initialize expression, you're only allowed to set it during that initialization phase. Once you go beyond that, it's immutable. So these are basically immutable properties. Now, one change they've made in C#10 is that when they were looking at record structs, they kind of rethought what it means to have a record class. And they've decided that really record is a modifier. So it's a modifier for class. So they've now made it so that this syntax will work as well. So you can say record class coordinates. So that wouldn't compile in C#9, but does compile in C#10. But of course, for backward compatibility, record coordinates still works because it's implicitly a record class. But this is the way you should be thinking about it. It's a modifier. So in C#10, the addition is now record struct. So you can, put the record modifier in front of your struct. You've now got this short format you can use if you want, or you can use that longer format. And this, I'm going to show you what this does in a second. This does mostly what you might think if you've used records for classes. But there's actually one little gotcha, which is structs already have a way of opting in and out of mutability or immutability. and that's with the read-only keyword. So when you have a struct, when you have a record struct, it's actually mutable by default, which was a surprise to me, but I understand it because otherwise, some of these keywords would be inconsistent. So I'll most likely be using read-only record struct when I use this, because you often want your records to be read-only. So to just explain why you want the read-only, let me show you some generated code. So here's a Sharp Lab example I've got. Hoping you can see this. So here I've got a record struct called coordinates with a long and lat constructor. And if my head isn't in the way, hopefully you can see that we get a compiler-generated class, or not class, apologies, you get a struct, as you might hope. We get the backing fields, and it's generated the properties, and they get set properties, so they're mutable. Just to show you what else you get in a record, you get the constructor, you get a corresponding deconstructor, you get a pretty print toString that shows you all of the properties. It also gives you the not equals operators that are based on value-based equality. It also has the corresponding get hash code that corresponds to that equals implementation. So this is one of the important things why you want immutable records, because if you were to change a property in a record, you've now changed the hash code. So if you had that as a key to a dictionary, you've now just lost the key to the dictionary effectively, because the hash code's changed. You kind of just got an orphaned item in a dictionary. And here's the deconstruct method that it creates for us. So just to show quickly, if we say read only, we now get everything here's the same, except we have the init keyword on the properties. Oh yeah, and just to show everybody, so this is sharplab.io. It's amazing. When you get here, it defaults up here to default. If you change it to the Roslyn branch, you can try this right now and have lots of fun with it. It's pretty cool. When you're working with records and you have the immutable versions, you want a way of being able to kind of work with them and change them, but obviously you can't mutate them. So there needs to be a way of working with them. And so we have the with keyword. So I can comment this code here. And I'm going to switch it to run. It'll take a little while. Basically, we can define a record struct here, and then rather than mutate them, you want to copy them with a change. So there's this with expression that was new in C#9. And for that with expression to work, the compiler, all it needs to know is how to clone that object. And the compiler knows how to clone records because it generates the code. So in a record class, it would generate a clone method. With structs, they're inherently clonable because you just copy by value. So they didn't need to do anything really other than make the with keyword work with structs. And in fact, they decided they'll just let any struct be used with the with keyword. So actually you don't need to use, you could have existing structs today and use the with keyword to mutate with changes because the compiler knows how to copy it. The same is true for anonymous objects. The compiler knows how to clone those as well. So you can use the with keyword with anonymous objects. I don't know why you would, but it's a new thing. So that's record structs, and that's showing some of the syntax. There's definitely a whole talk in record structs that I'm not going to do because there's so many other things to talk about. But if you do want a deep dive, I can really recommend David Wenger's NDC Melbourne talk, where he goes deep into record structs, lots of the syntax, lots of the nitty-gritty details under the hood. So yeah, definitely check this out. I'm just going to scan for questions for a second. This might take a second. So I appreciate everyone's muted and I'm just flying past it. Right. Is it all or nothing with namespaces? You have to clarify what you mean, Ian. We've got a question about, is global usings an alternative to dictionary.props? No, it's not. However, you can, that's a good call. You can actually use directory.build.props to have system-wide global usings if you wanted. That's an interesting suggestion. How do you manage merge conflicts? If you're talking about how do you manage merge conflicts? If we're talking about the namespace
I think this
declarations.
was the global usings, I think.
Oh, how do you manage? Yes, yeah, good call. Okay, that's a really good question. So you can either at the top of the file yourself kind of be explicit with an alias and say, like, for a really good example is the Microsoft teams themselves dogfooded this feature, and the MS Build team have MS Build task. It's like pretty ubiquitous in that code base, which clashed with system.threading.tasks task. So you can at the top of your file say using task equals whatever, and then kind of override it and disambiguate it. But you can also do that in the global using CS or in the project file itself. I showed that you can use an alias. So you can have a global using alias to disambiguate across the project. So you've got all sorts of levels of control. If you switch this on and you get a bunch of clashes, then that is going to be painful. But I think those cases where you get like that task clash, that should be few and far between. You're probably already running into little clashes here and there. But of course you can use per file or per project disambiguations with aliases. Will records work with Newtonsoft's deserialization, serialization? Yeah, so the init-only properties are a language feature, and in the runtime, you can actually ignore them and set them regardless. So Newtonsoft JSON, older versions will just do it blindly because it won't know any better. And newer versions, I don't know, but yes, basically records you can use with Newtonsoft JSON. I have to say, I haven't had much experience serializing, deserializing two records, but I believe you can. Can you make changes to some files rather than all files? From Ian again, is it all or nothing? Yeah, it is all or nothing. It's everything within the project, basically. Everything within the compilation unit is what gets the global using namespace. So I don't know of a way of saying like, hey, this file is like, maybe it's auto-generated or something. I don't know of a way you can kind of opt out of saying, hey, this file is like, not to be included in terms of global namespaces. Like you can't have a directive at the top that says like, do not want. So yeah. All right, I'll check this every few sections. So better lambdas, right? So lambdas arrived in C#3, and in my opinion, probably the best language feature and the most like fundamental change to the language. And I include like async and nullable reference types. I think like this is probably the most fundamental change. And this came about to sort of enable link. And lambdas are awesome, is what I'm trying to say. But lambdas haven't really changed since they arrived. They've had very few, changes to them as a language feature. And there's a couple of things that are super annoying about lambdas. One is that there's a sort of feature gap between methods and lambdas in terms of like attributes and, in, out, ref parameters and all the rest of it, and return types. And the other is just the usability of a lambda. So whenever you're using a lambda, you can't just have a floating lambda somewhere to really show an example. You have to cast a lambda to a delegate. And so here in the top line, we're literally casting it to a delegate, or you might use the delegate constructor. But whenever you're using something like link, where you have like select and you have a delegate in there, it's that delegate that's implicitly casting a lambda, and that's why it can accept a lambda. So, lambdas are great for when you put it in a method that expects a specific delegate type. However, we can't pull it out and just put it in a variable because it's super ugly. We have to do this with it, right? And that's changing. So they're adding the concept of, or they've added even the concept of a natural inferred type for lambdas. And this is huge, in my opinion. So if we take let's go from function 4 here, you can just say like var f equals some lambda, and if it can infer the types, it's going to work. So it's going to infer a func int here, an action in on the next line, If you use async, it will infer a task. And you can also just pass take a method group. And so here, get hash code without the brackets at the end. But that only works if you've got one overload. So a method group of size 1. So get hash code, there's only one version of that. So it's going to infer func of int. But for toString on int, there's loads of overloads to that, and it's not going to know which one to pick. So that's not allowed, but all these others work. These top 3, it's not going to know what this null is. It could be any reference type, or it could be a nullable value. Same for this next line. It's not going to know what that input is. We have to tell it. It's not like F# and functional programming languages in terms of its type inference. It's not going to follow through where you pass that parameter to say, I see you've passed it into int.parse, and that means it's a string. You have to tell it in terms of the input parameters. And also, it's not like F#. It won't auto generalize. So in F#, this is known as ID, where you take, input and just return the output, and it would be auto generalized in that. But in here, it's not. You can't just. There's certain rules that we have to stick by. But otherwise, it's super exciting. I love it. Another major feature they're adding is explicit return types to lambdas. So in that example I gave before, where F1 didn't compile because it doesn't know what their null is, we can now say, just like in a method where you have the return type on the left, we can say that the return type, and now it compiles and it knows that's the function string. So that's super cool. When you're using this syntax, you have to put the brackets in. So there's a special case with lambdas where you have one argument, you can omit the brackets. The compiler just can't do the syntax parsing gymnastics when you're using a return type. So whenever you're using a return type, you always have the brackets. That's something to note. And so something else they've done is to close the gap on methods. They have added the ability to have attributes. So you can have attributes on parameters, attributes on the whole lambda itself, just as you'd have an attribute on a method. And if you want to put an attribute on the return type, you can actually put in here return : something. And that attribute then applies to the return type, which is awesome. And these features I've just talked about, maybe with the exception of records, but a lot of them all play together. So a lot of these features have been driven from a use case, and a lot of them sort of championed by David Fowler on the ASP.NET Core team. So he wants a sort of appealing, really minimal, lightweight way of defining APIs to get sort of new people into .NET who, they may have seen things like Express.js and other frameworks where it's just, so succinct and easy to use. They may just, want to pick it up. And that's something we don't really have with C#. We do have nice, simple templates, but they're not something you can just sort of put in a screenshot on Twitter and get people in, right? But that's changing with minimal APIs. So these features, so we've got top level statements, which came in C#9, global usings, inferred lambda types, explicit lambda return types and attributes, and then the new APIs they've added to ASP.NET Core in ASP.NET Core 6 gives us these minimal web APIs. So this is kind of one of the driving use cases for it. And like the simplest version of this, I guess, is just a 4-line app here. And this is a full application, right? This is the one CS file, compile and run, and this works. So this is taking advantage of global usings, top level statement. So there's no program class, no main method. This lambda here, I'll get onto that in a second, but we would have to cast this to a specific lambda type before this feature. So that would have been super ugly. And so this just works, which is really cool. And obviously, this is a naughty example. We want better examples. And so they've made it so you can grow this, and it supports more use cases. And eventually, let's say it grows too big, you might want to grow it up into MVC with controllers and actions, but you don't have to. You can kind of. So here's a bit of a more involved example. This is from Damien Edwards, and there's lots of little examples out there. Dave Fowler's got some examples, and this is a map get. Something to call out is that yes, you can do things with attributes, like you can have like produces attributes, You can have like authorize attribute, but also this builder, I'll show in a second what this returns, but it returns us a builder. We can also use the probably more idiomatic in this style to say, you know, produces this return type, dot authorize, and kind of configure the endpoint with extension methods. But you know, we also have the attributes we have for action methods where you can put in like from body and all those sorts of things. In terms of the parameters here, it's very clever. It will bind this to the root constraint here, the ID. If we've registered a service like the to-do DB in our service collection, it will pull that out and give it to us. If I go on to the next example, actually, before I do, this returns an I result, which is just like an action result. So we can have a OK with a JSON result or not found. It will return the various status codes. And if we ask for a parameter that's a type that isn't in the service collection and it isn't in the root or whatever, it will then try and in this, I don't know why it's called to do service. I think I renamed this wrong. This should say to do. It will deserialize it from the body. So it's kind of, it's a bit smart, but of course you've got the attributes to be more explicit if you want to be. This example, by the way, Damon Edwards has a little wrapper for validating against data attributes. So he's using that here. That's kind of cool. I think this is a really nice pattern. So yeah, this is super nice in my opinion. The way it kind of works is before ASP.NET Core 6, we had this version of map_get, and map_get took, you know, it's an extension method on a builder. It took a pattern for the root, and then it took a request delegate, and this is all we could do before, right? And we were very rigid in terms of what delegate we could use. It had to be a request delegate. It had to take thing of a certain shape. But the new one returns us this new builder. That's why we can add more interesting attributes to it, things to it. But it just takes any old delegate. So we can put in anything in there. And it doesn't have to be ugly now because you don't have to cast it to a specific delegate type. And at runtime, it's going to just wrap that with whatever it needs to call. So there's something called a request delegate factory that it wraps it with, so that then passes the right parameters into it. So that's how these Lambda improvements enable this capability. It's super cool. I'm going to pause it there. I think this is probably a good time to take a break. If everyone wants to grab a glass of water, I'll start scanning through the questions and seeing what we got. We've probably got a lot of questions around that. Let me just take a look. I think I showed something ugly at one point. Yeah, Dan says, not sure he likes the method group usage. Almost like F#. That's a fair comment. Ian says, what do all the bangs do? That's the nullability, nullable reference type. So in .NET 6, they've got all of the APIs attributed in terms of like whether it's nullable or not. So, you know, string exclamation mark means it cannot be null. Does the C# 10 runtime support ARM64? So, yeah, it's the .NET runtime. So .NET 6 does support ARM. I'm really hazy with my architectures in terms of ARM and ARM64. I know it supports ARM and it supports the M1 Max. Anyone else want to chime in with ARM64 support? I think it does. Okay. All right. Okay. I'm gonna carry on. So The next one I want to talk about is caller expression attributes. So this is a bit of a niche feature, but I think it enables a really cool one I want to show. So with caller attributes, this is part of an existing set of attributes that exist in C# and .NET. So previously, we've been able to say things like caller member name. And what you could do is you could put this attribute on a parameter. And when you do that, the compiler forces you to make it optional. And so we have to say that it's nullable here. And that's because when we call it, we aren't allowed to pass in this value. And that's because the compiler is going to pass it in for us. So if we say caller member name, for example, it's going to pass in the member name from the call site. And so that could be the method that we were in, or it could be the property name that we were in. In this case, I've done it in a top level statement. So the top level method name is main dollar because it's an unspeakable name. But we can do the same with caller file path and caller line number. And this is sometimes really useful for debugging when you have like an assert exception. Grabbing these things to see where you were calling from can be useful. But a really nice one they're adding to this family is something called CallerArgementExpression. So what you can now do is you can, in the same fashion, it has to be an optional parameter. You can say CallerArgementExpression, and then you give it the name of another parameter. So here I'm giving it the name of the input parameter. In C#11, they might be adding name of support in attributes pretty much for this feature. So you'll be able to say CallerArgementExpression of a different argument, different parameter. And then what that does is the compiler will pass in the caller expression of that other attribute. So to make it clear, in this case, I'm passing in this expression as the argument for this parameter, as the input parameter. But what the compiler gives us in the input expression is literally that string, like from the source code, that string. And again, this is super useful for debugging. Like if there's libraries like Fluent Assertions and Shouldly, these assertion-based libraries, where you literally want to be able to say like that expression and then show them the expression. We expect it to be null and it wasn't, and it's super helpful to just show it. And so I think this is super niche. You probably won't have to touch this, but one of the very interesting places where it's being used is in this static method and this was the shipping with .NET 6. So you can now say argument null exception dot throw if null. And this takes the argument and then takes the name of it and will throw an exception with that name. And what that means is we no longer have to do the kind of like, if this is null, then throw exception name of blah, blah, like the typical null checks that we do. We can now just write argument null exception, throw if null, input. And you may say, oh, I've seen this sort of thing before. You may have seen like, I don't know, guards and sort of throw helpers, but none of them have been able to do this, where you can take the name of the parameter by having the compiler tell you the name. So this is like a really nice thing they've kind of leaned on here, and I like this a lot. So that this is probably something I want to use a lot in .NET 6. String interpolation improvements. So there's a couple of features around this. Just reading Ian's comment. A couple of improvements around string interpolation. One is a very simple one, which is const string interpolation. So we've been able to do string interpolation, but not in a const string because it's compile time static. But if I'm using other compile time static values, surely that should be allowed to work, right? And the common case we have for this sort of thing is, attributes have to be compile time static. So when I put a string on an attribute, I can't string interpolate. Well, now we can in C#10 because we can now do const string interpolation. So this now just works. And I think this sort of example is a realistic one. So that's kind of nice. Okay, the other thing, the other feature that's probably a bigger one to call out is something called string interpolation handler. Now, a big caveat here right up front is you do not need to know this. Don't worry about this. Don't. If you want to kind of half switch off, fine. There's indirect benefits we're going to get from this, but it's interesting to know that this is a thing. So what they've added is this idea of a interpolated string handler. And basically, it's a type that you would create, and you'd put an attribute on it to say it's interpolated string handler. And it needs to be a certain shape. So it has to have these methods: toString and clear, append literal, and append formatted for whatever types it's going to support. And there's rules around what the constructor can look like. So the compiler kind of enforces all this and kind of does a duck typing thing. And once you have a string interpolated handler, there's two ways. Well, there's one way that you can effectively use it, which is having an overload to a method that takes not only a string, but also a interpolated string handler. And when you do that, your overload that takes the interpolated string handler will win, and you'll be able to handle the string interpolation, which you almost certainly never want to do. The use cases are there. There's a blog post that Microsoft have done recently where they call out a really good example where you would want to use this is if you had an assertion library and you wanted to do an assert for some condition that's true or false, and you want to say it's true. In the case where it's true, the error message you wouldn't want to evaluate. You wouldn't want to allocate the string. You wouldn't want to evaluate the holes in the string interpolation. So that's a really good example of where you could use the mechanics of this to kind of trim off some excess work that you wouldn't want to happen. But the biggest place this is being used isn't through us using this, but it's by the compiler itself. So this default interpolated string handler is actually a type that will ship with .NET 6. And what it will help with is this scenario here. So when we just do regular string interpolation, what happens is the compiler lowers the code, and that's something the compiler does. It basically rewrites your code to more ugly code before it does the proper compilation. And so when we do string interpolation like this, where we say first and second, and we string interpolate them together inside of a literal, a number of things can happen. If it's just a string inside a string, or use string concat, but often we'll end up with a string format call. This is what gets lowered from the compiler. And in this case, string format isn't the most performant way of doing this. There's a few things in it that are not ideal. And one of the things in this example that's shouting out to me is we've got an int here and a string. So in terms of the overload for string format, the only overload that's going to match this is object. So that int's going to get cast as an object, which is boxing. So it gets copied to the heap, and then it needs to be garbage collected. So there's a lot of wastage there. And it's nothing you should lose sleep over, because this is nano optimizations. But we do this all over our code, and not just our code, but the code we consume in the libraries we use. So it all adds up. But when we have in C# 10, if it can find this type, so this is what's called a well-known type, the compiler knows about default interpolated string handler. If it can see it when it's trying to compile, it will try and use this instead of this lowering method. And what we'll end up lowering it to is this version. So it will actually use this default interpolated string handler. And the important things to call out here are, as you may have noticed from the implementation, it was a ref struct. So it's not going to allocate anything. It's a stacked thing. It can use spans as fields because it's a ref struct. And so it's going to borrow an array from the array pool, put that in a span field, do what it needs to do, and then materialize the string at the end. So we only pay for the string. It's super optimal. But importantly, the append the append formatted method here is generic. So it's of type T. So in this case, we aren't going to be boxing. We're not going to be casting that int to anything else. We're not going to cast it to an object. So it won't get boxed. So everything just gets faster, basically, is what I'm trying to say. If you compile against C# 10 and .NET 6, things get ever so slightly faster. But it's just really nice to know that this is something we get for free. Another thing we're going to get is extended property patterns. So this is a very minor addition, in my opinion. So before, when you do property patterns, you could, if you wanted to sort of pattern match on something that's deeply nested, and in this example here, we have caller method expression. We match the type, but we want to match on the method name, which is nested inside of the method object, method property, which has some object that has a name property, and we want to match on that. in C# 10, we can now just dot into that in what's called an extended property pattern. And so this is null safe. It won't blow up if method is null. And it's just a nice little win. We were also going to get some list patterns. There are 3 list patterns that were going to be introduced. However, Microsoft asked for some feedback on Twitter, and the sort of consensus was for one of those patterns, people weren't quite happy with the syntax. So that's one that's being pushed back, or it's being taken back to the drawing board, and the language team are going to see if they can have a better go at it. And it may or may not make it into C# 11, depending on what they can do with that. Here's another one. So this is a C# 11 one again, and I'm gutted about this one because I was really looking forward to this in C# 10. So it's something called required properties. So in C# 8, they added the idea of nullable reference types, and that is new syntax where you can say string ? And that means a nullable string. Well, strings were always nullable before then, so that's not really a new idea, but the new idea is regular string without the question mark is a non-nullable string, and that's a new concept, or it was at the time in C# 8. So we had these non-nullable things, and that meant that we could kind of get rid of lots of bugs because we could be kind of explicit about where things can be null, where things can't be null. And the idea was you'd go through all of your projects and you would switch this on, and you would sort of chase through all the annotations, and the number of sort of compiler warnings you'd get would explode like virally, and then you would address all the problems and they would converge down to 0 and you'd be done. And that's mostly true, but for me, I always struggled with it because I would have classes where they would be like this, where I wouldn't have a constructor. And in that case, I'd have a property like name, and I know this thing can't be null, but the compiler tells me off and says, no, 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 you're not setting this in the constructor. This thing can't be nullable. So this second property here, you were forced to do it like this. You couldn't do this top one. It would break the nullability rules. And so I was kind of saddened by that because this is how I often use classes, and I'm being told that I can't express the thing I want to express. But in C# 9, we had that init property, and I was excited by that because I thought, well, if I have an init only property that's non-nullable, then this is going to solve it. The compiler is going to force me to set that when I construct it. But it turns out it doesn't care. What the init property does is it means you can only set it during the initialization phase. You can't set it after, but it doesn't mean you have to set it. So I still can't express the thing I want to express, which is that this property cannot be null and you have to set it when you new it up. And I don't want a constructor. And so that's what this feature would solve. And so the idea is you now have a required keyword where you could say public required string name. And this does exactly that thing I just said. It expresses the idea that you must set this. And then the compiler warning goes away. I can actually migrate my existing code by sprinkling some required non-nullable things about. And that's what I want. And I saw this from a presentation by Mads Torgersen, which I'll link to at the end. And I was confused. I was like, well, why have I got the ability to say that this thing is not nullable, i.e. not optional, but it's required, which is also not optional. So I'm saying it's definitely required. And he persuaded me that actually these things are orthogonal concerns. So to make it really clear, I don't have the slide I thought I had. The slide I'm missing is you can put the required keyword here. You can say public required nullable string pet's name. And in this case, you're still required to set the property, but you might set the property to null. You might set it to something that could be null. So required keyword is about whether you have to set the property, whereas nullability is around whether the thing can be null or not. So they're different things. So that's something for C# 11 to look forward to. In a similar sort of theme, there's this one as well, exclamation mark, or bang bang as it's sometimes referred to. So this is slipped. This was aimed for C# 10, but slipped out. Will likely be C# 11. All the syntax may change. It's all up in the air. So you may have enabled nullability in your project, and so you may have a public method in your library that's non-nullable, and that's great. So if someone's consuming this, they might if they're consuming it from their own code where they have nullability enabled, they'll get like compiler warnings to tell them this can't be null. You can only pass in a non-null string to this. However, if someone's calling it from a library that doesn't have nullability enabled, then they're not going to get any warnings at all. So they can just pass a null in here. So what you should really do in this code is you should still do a check for null. I used to say, because it's a public method, was this thing null? And the problem with this is you look like you're arguing with yourself. You just said this string can't be null, but if it is null, then I'm gonna do a thing. So you kind of look crazy, right? And so this syntax is to kind of tidy that up so that you just say this is a non-nullable string, and then some syntax to say but check, and basically it would write that method for us. It would do that check at the top of the method. So it's just a quality of life thing. This one isn't going to make it for C# 10, but I'm not bothered by this one, to be honest. I was gutted by the required one. That was the one I really wanted. Another one that's, this was never aimed at C# 10. This is always going to be a C# 11 one. This is raw string literals. And this is one I'm super excited for as well. This is another one of those things where F# has it. And I love it from F#, and I want C# to have it. So at the moment, when you're using strings in C#, string literals, it's really hard to like express XML or JSON, because you have to escape it, and there's lots of ways you can escape it, you know, depending on whether it's a what's the word, a verbatim one or not. But what raw string literals will do is you can have this triple quote mark, which says it's a string, a raw string literal, and then effectively, if you line up the other triple quote, this string is everything from this column to the right. So you don't get the white space here. Now, this is optional. You can actually shift this to the left and you'll have all the white space in there. I have to admit, I haven't read through all of the rules around this. So if you have lots of questions on this, I'm going to be a little bit gray. But this is super handy for XML, for JSON. Again, in F#, I can do this and I love it. One thing they're looking at, and I think this is actually in the spec as it stands, they want you to have the ability to use this with string interpolation. So if I'd put $1 at the front of this, I could do string interpolation. However, if I had some JSON, that single curly brace is going to clash with regular JSON. So what they're suggesting is you'll be able to put a number of dollars at the front of this. So let's say $2, and that indicates the number of curly braces you'll need to escape into the interpolated string C# world, which sounds a little bit like arbitrary, but actually it's super practical. It means that if you're dealing with JSON, you would put $2 at the front, and now you can string interpolate a JSON object where two curly braces would break into C# and out of JSON, if that makes sense. Going to look at the comments for a second. Someone said the required attribute is now keyword. Yes, good spot. Who let the F# guy into C# talk? Thanks, Dan. Yep, yeah. Are there any plans for triple equals? I presume you're trolling Ian. They could be, who knows? I don't like the syntax, I'll be honest. Dan says, I love that it removes the indentation. Yes, yeah, the multi-line thing. So this is, I think this is an optional feature of this, but this is one of the things they definitely want, is the ability to, and I'm going to just like make up the future as I go along, but I'm hoping that IDEs are going to like render this nicely and give us like a little border here, just to emphasize the fact that this multi-line raw string literal is actually not got the white space in. That's what I'm hoping for. Here's another one. This was aimed for C# 10 and it slipped out into C# 11. And it's a very minor one. And I'm probably going to spend no more than 10 seconds on it because it's exactly what you think it is. Generic attributes is the ability to have an attribute that is generic. Before, if you wanted to pass a type into an attribute, you had to say type of and pass in type as a parameter. Now you can have type arguments. And actually, here's a use case where you can't do this today with what we have existing. If you had a base class that was generic of type, generic with type argument T entity, you couldn't then use that inside of an attribute. So we can now use open generics with this if this lands, and it should land. So that's nice one. Also, it's aesthetically nicer. That's the reason I like it. I think it's prettier. And then this is the last one I'm going to talk about today. So this is an interesting one: static abstracts in interfaces. So this is a really interesting one in terms of the way that it's positioned, the way that it ships. So with most of the features, they land with a particular language version. This one is peculiar in the fact that it is in C#10, but it's in as a preview. And it also is one of the few language features that requires a runtime change. So just like we had back in C#8, a runtime change for default interface methods, or default, I forget the actual, it's DIMs, right? They had to do a runtime change to support that. The same is true for this. This is a runtime change. So you have to be on .NET 6. And they've put it behind a feature flag, and I'll explain why in a second. So you actually have to switch it on. So you have to enable preview features, and then you have to include a separate runtime package to try this out. And that's because for this feature, the feature itself is interesting, but it enables some really interesting use cases with the math primitive types, the numeric primitive types in .NET. And so it's going to enable better abstractions over numerics and more generalized math code. And that's super scary. This is why it's behind a package and a feature flag, is because they're going to add interfaces which have, which require runtime support to primitive types, which is a super scary thing. Hence why it's behind a flag, and they want feedback in this language version, basically. So this is the feature in its simplest kind of form. You can now have an interface where you define a static abstract member, and now anything that implements this interface must have a static member that matches this definition. And you'll typically see it defined like this, where you have a generic interface of T, where T is the generic interface of T. Now, if you're familiar with C++, this is called a curiously recursive something template. I forget. There's some 4-letter initials for it. But if you come from that world, you'll know exactly what I'm talking about here in terms of it kind of comes from this template concept. But what this will let you do is, if you implement a type that implements iaddable of T, where you implement this idea of 0 and this because as well operators are static, where you implement a plus operator, what they can do now is they can take the have int32 implement iaddable, implement the well, it obviously already implements the plus operator, but add a 0 definition, and now you can have generic algorithms. So in this example, you can have an add all thing where T is iaddable, and now on the generic type here, the generic argument, we can do dot and then dot onto static things and use static operators. And so this means that and if you imagine that every primitive numeric in .NET implemented iaddable, which is the plan, and a whole bunch of other things around multiplication, division, and any maths you can think of, you can now define generic algorithms. Some of these you wouldn't want to do yourself. For example, like you could do it for standard deviation, but there's already out-of-the-box implementations for standard deviation. But like even a couple months back, I needed to implement a geomean implementation, and I couldn't find one. And I had to do it like 3 times for ints, for floats, and for decimals. And now I could just do it completely generically with no performance overhead. It's just like writing regular C# code, but it's now more abstracted in terms of the mathematics. I had to be honest with you, I haven't thought about the applications outside of the sort of the mathematics sort of area. I'm sure those who've done this with C++ might have ideas. But yeah, that's just a super interesting one, and one that you have to go out your way to switch on. So that kind of concludes what I'm going to talk to you today. There's lots of features. There's a few other features I haven't talked about but you can find out more. I've done a talk on C#9. I link to here. I'll share the slides with Dan, and we'll put them on the meetup. All of the stuff I've sort of put together here, I've drawn from the language design discussions. So there's a repo here that has all of the proposals and the proposals for C#11 if you want to know more. but I'll paste. Let me paste the link to this one. I'll paste this in the chat. Someone said Haskell type classes for the for that last feature. Yeah, pretty much. Yeah, it's in that space, definitely. Oh yeah, actually, let me show you. So this repo is the language design discussions, and they have frequent meetings where they talk about this stuff. So this is how you can find out about the status of something, if there's problems with certain features, the conclusions they come to on particular pain points. Another great one is this page here. This is on the Roslyn repo, and it has all of the features, all of the branches they were implemented in, and links to the spec. And so this is how you can see what's coming, what's actually going to make it. And this only changed like not even a week ago. Like before a week ago, there was only a few things in C# 10. I was kind of like winging it in terms of what was going to make it or not. But now a lot of things have been committed to 10. Some things have been slipped to 11. But you can find it all out in this page here, and it's updated every now and then. And finally, Mads Torgersen did a really good talk last month. Well, actually, I think it was the month before that, that I've linked to here. So again, when you get these slides, you can link off to that. Thanks very much. You can, again, get hold of me on Twitter, and I blog at stuart.dev. Let me jump over to the questions and see what I've missed. Actually, maybe this is a good time to unmute, and I can actually take things verbally, because that might be better. I'm just reading through the comments again now. There's a bit of banter between the F# and C# folk. Someone,
By F#, you mean Ian?
Well, I wasn't going to name names. I consider myself in the F# camp as well, so it's me and Ian versus the world. Stefan also saddened like me that some of the core features were postponed. Yeah, for me, raw string literals was never going to make it, but that one I'm really looking forward to, as well as the required keyword is something I really need. But everything else, I'm really excited for C# 10. I think it's super cool.
I love the namespace one you showed for the file level namespace. Yeah,
and I think there's been some love-hate on that. You know, it is a bit subjective on that one. I do like it. There's people who think that, you know, hiding things is problematic, but I do think it's solving a problem, and I definitely like it.
It feels very similar to the switch, not the switch, sorry, the using.
How do you mean? Sorry.
Not the using. And do you know which was it? C# 8, the using block.
Oh yes, yeah, I know what you're saying. Yeah.
So basically, where they've taken out the braces and moved the indentation, they're pretty much just doing the same for namespaces. So
yeah, namespace is that exactly. Yeah, and I think for namespace, I don't like if someone wants to challenge me and tell me how it's. Like, I think there's literally no trade-off on that one. That's one I think hopefully we can all get behind. The namespace declaration one is a win. And just to hammer home again, like when you say file new project in .NET 6, the namespace declaration will be default in the template. Global usings will be on by default, so you have to switch it off if you don't like it. So this is kind of what modern C# code is going to look like, unless there's a massive pushback from the community and everyone decides it was a terrible idea. But it looks like this is what modern C# will look like. So I think those will get good adoption.
Does anyone actually have a namespace block that's not the whole file anyway?
Microsoft have numbers on that, and it turns out no. Like you generally don't have multiple namespaces in a file. If you did, it's for like demo purposes or test purposes or something like that. I'm sure someone out there is going to say, no, I do. But in general, yeah, people have one namespace per file. So, and Microsoft have the stats on that. I think they said it was like 0.1%, but that seems high. I think it must be like it's got to be less than 0.001, I'd have thought. In showing off some of the string interpolation features in F#. I've got to say, I love F#. Some of the features coming in F#, 5 in .NET 6 are excellent. I love them both. They're both like, I have a special place for both those .NET languages. I just have no love for VB, unfortunately. Maybe that's just because I've never been fully exposed to it. Does anyone have any other questions? I'm scrolling up through trying to see if I know I've missed some, and I'm happy to slide the slide backs as well. Slides back to if people want to point at code.
Do you think that? Well, so I've seen like two camps of people when I'm showing later C#8, like C#8 or C#7 functionality, and some are like who are used to more functional programming, like love the new C# stuff, but then there's another camp of developers which find the new functional aspects of C# hard to read, and they really push back on it and hate it. Do you think this is going to make it even harder for them?
Yeah, I think with every new version, there's always some pushback for some people. I think this one will be a bit more again for some people. This will be like a step too far with the global usings, I think. But I don't know. On the thing is, right, either a language stays still and becomes irrelevant, and in which case, whatever desire you have to like keep the thing the way you want it, that's going to fail because your language becomes irrelevant. The jobs that exist to look after code will be using different languages. And so, you know, if you think of it in terms of like the long game, you need the language to evolve and stay relevant. And that means it has to change. And that means that we get more. I think a lot of people hate the fact that there's more than one way of doing things. I think for a long time, we've had this sort of like very privileged position where we can look at JavaScript, you know, the good parts and JavaScript and kind of have a little chuckle to ourselves. But really a language that evolves is going to have that. We now have like C#, the good parts, and just all of C#. And there's lots of bits that are just like old ways of doing things. But I think that's a necessary thing for something to stay relevant.
If global using it only ever gets used for system.link, I'm sold.
Yeah, fair comment. Yeah, system link is one of the ones they've included in the defaults if you switch on the implicit ones. So that in new projects will just be there. But yeah, system link's a good one. But then I don't know, they have system.io in there, and I don't know how I feel about that. But yeah.
I'd be interested to know with the new cadence of C# languages or C# versions being the same as .NET, whether in a few years they're going to be like forced to invent new language syntax just to update the version, or whether they're going to just say no, actually there's not going to be no more C#9 in this year.
Yeah, you know, I don't know. I mean, I would always imagine they'll have lots of minor things. There may be releases where they're all just very minor things and no heavy hitting features. But I don't know, even if C#11 only contained the ones I just talked about there, I'd be pretty happy. And I'm sure they definitely have other things on the radar as well.
Yeah, I think it gives people like time to catch up as well. Because I know like not everyone, this came up on Twitter actually, and yesterday, and we're talking about new C# language features, and I think it was Adam actually was mentioned that like not all workplaces can use the latest and greatest. So when they eventually can, they've got quite a few versions to suddenly catch up on and learn.
Yeah, that's a fair point. Yeah, I do. I'm blessed sometimes with having the latest bits everywhere.
Well, that was my reply. I think I replied to Adam saying, "Yeah, I feel very spoiled right now because I'm using C#9 at the moment for all my projects."
Yeah, I think definitely if you're on .NET Core or .NET now, you know, the new .NET, it's just that the whole tool chain has become so much easier to move with. So once you've got away from .NET Framework, or yeah, then you're in a good place. Some places have the long-term support requirement, and so you only go every 2 language versions. That's fair enough. If you're building, I don't know about Unity, that's that's an interesting one. I don't know about language support, how that works. Mono usually gets, like, I know that C#9, they had language support on day one in Mono, but they didn't really, no one really knew too much about it. It was like not very, I don't think it was very well advertised, but you can use all the C#9 features in Mono. So if you're building Xamarin apps, but I think when .NET 6 comes and everyone moves from Xamarin to .NET MAUI, I think that everything gets easier just to move along with the bits. I think it'll be easier to take the language updates. But for those who are the other side of the big gap and on .NET Framework or on, using Mono maybe, that'll be difficult. Cool. Well, if there's nothing more, then I'll switch the slides off and hand back. Thank you.
Cool. Well, thank you so much, Stuart. That was amazing. I've not had a chance to look into C#10 at all yet, so that was like really informative. And yeah, I'm quite looking forward. I was looking forward to November anyway because of like Blazor Desktop. There's a few different features I'm quite looking forward to. Like what's the I always forget the term where the hot reload, is it?
Yeah, hot reload. Yeah, that's going to be great.
Yeah, so this has given me quite a few more really cool things to look forward to. So just to echo for everyone, the what Matt said in the intro talk, a big thank you to our sponsors. So our primary sponsor is Curricular Recruitment. You're still spotlighted, by the way. I'm just going to remove that. I think, has that worked? I don't know. Yeah, they've been our primary sponsors from the beginning. And yeah, obviously when we were physical, they were paying for the venue, lots of liquid refreshments and drinks and everything. So amazing there. Now we're virtual for the time being, then they're paying for the Zoom license so we can have as many people as we have. And the secondary sponsor is my company, Everstack, providing software development and consultation services. And then obviously we've got our prize draw sponsors, JetBrains, 2 JetBrains licenses, Manning, and they said Oscode, then they're an ex sponsor, and Packets. And so we're going to hang around. Whoever wants to hang around, we normally have a virtual pub session afterwards. So we're just like chat and geek out. Stuart, are you hanging around?
I actually need to fetch my kids from the pub. An odd one.
All your kids?
Not one off to the pub. My wife's doing a pub quiz, and so she's like, "I'll take them to the pub while you do your talk, and then when you're done, get over here and get it back." So yeah, I do actually have to like dash off. I'm really sorry.
Fair enough. But thank you so much for joining us.
Always a pleasure.